So, Justin, what is the problem that you're really seeing with the industry right now and that, say, contractors are trying to face, or even facilities teams for that matter? Like, what is the main problem?
But there are really two things that we looked at, and it's two finite resources that we all have. It's time and money, right? And so specifically with compressors, downtime and the cost of replacing them, along with a lack of manpower or um, the proper level of technician to work on certain equipment. We saw a problem with wasted time, wasted effort. And so we took an active approach at looking to solve both of those problems, specifically from a compressor manufacturer's point of view, and then try to apply that to the overall system. So the way we're able to do that is to smartly monitor and then smartly dispatch technicians to problems that were being identified before catastrophic failures.
I got you. So, with that, you've developed the SAMMI system.
That's correct, yeah.
So, with SAMMI, you're able to, I see plenty of sensors here. So, I see some thermistors, some transducers. We're able to get a basic snapshot, and you would have this, I'd assume, per circuit or per unit. And
Correct.
then from there, it's communicating to, you said an AI?
Correct, yeah. So we use Amazon's supercomputing, AWS, to run algorithms to help detect and alarm issues that are going on with HVAC systems, refrigeration systems that are compressor centric. So you pointed out all the sensors. SAMMI comes with 7 sensors, so we're measuring temperature, amperage, and also pressures. And from that, we can deduce through the app things like superheat, subcooling, approaching lock rotor amp, so on and so forth. So we're taking all the same measurements that a technician would as soon as he gets on site to try to diagnose a problem. We're just taking that continuously during the run. So from a 100,000 foot view, it's smart monitoring. So it's going to collect and dispatch data via cellular. So we don't have to worry about Wi-Fi connection or Bluetooth or anything like that. Once it's powered, the modem connects to the cellular network, and it's a international SIM as well. So no matter if you're here or Latin America or Europe, it's still going to connect to the network. But once it's connected, it's going to send the data that it records every 5 minutes in a batch, unless there's a problem.
Right.
If there's a problem, it will alarm instantly that there's an issue going on with any one of the algorithms that it's running and finding an issue with.
And one of the things I'm curious about on the dispatch side, I've been in that operation side of it, and I know how tricky it can be to work with dispatcher. And so, if this is trying to say automate that process to a degree, but that's not the only customer we have either. So
Sure.
what parameters or what are the boundaries on how SAMMI could work with our existing dispatch teams we have?
Sure.
Yeah, what's that relationship look
So
like?
there's a desktop application that also goes along with SAMMI for the dispatch function. But what SAMMI does well is allows the user or the owner of the equipment to really dictate how SAMMI is going to work for you in a dispatch situation. So if your company currently has a dispatcher that works for you, SAMMI would just enhance that person's ability to know when alarms are happening and who is qualified and who is best suited to go figure out those jobs and those problems. So it's sort of the Uber model to where you've got your specifications as a user that you need a car that seats so many people and you're going this far away from where you're at. Well, they're going to pair you with a driver that's nearest to you that can also handle all of your specifications. SAMMI does the same way. So if you have your most qualified technician is the furthest away, it normally works that job, but the problem that's being presented at the moment can be handled by someone with a maybe lesser experience, but it's closer. The user or the service manager or the owner of the company can set those parameters and will help with that. But they can set those to say, all right, well, in this particular instance, we don't want the closest person. We still want the most qualified for that job. So it really gives a lot of freedom to program that from the onset. And we can change it at any moment. So if you have other customers that are not using SAMMI at the moment, your dispatcher will see those jobs along with the SAMMI jobs, and you can determine, well, I want SAMMI jobs to take precedent, or I want other customers to take precedent. But that's all user specific.
I got you. So with that, like, what are the main applications you're seeing this, at least in the early stages,
Sure.
at a minimum, right? I mean, are we thinking any kind of space in the residential market? Or we focus like commercial refrigeration? Like what?
Sure. So initially, it's the ideal customer for this is somebody who is limited on those two finite resources. So if time is of the essence or liability is of the essence for loss of product, that's a target customer. So things like food storage, critical care units that have a need for air conditioned space, like hospitals or surgery centers, blood banks, those sort of things, to where a loss in refrigeration or even a loss in comfort cooling is going to cause a catastrophic issue. SAMMI is a perfect solution for that because SAMMI doesn't sleep. So if there's an issue going on, simple like a compromised capacitor, you don't have to worry about someone being on site monitoring that equipment via a human. SAMMI is monitoring that. And so if it is a blood bank, as an example, and we've lost a capacitor for the compressor, SAMMI is going to dictate that. SAMMI is going to detect that and then send out the notification at any time that says, hey, it's this system. We've run the algorithm. It says it's either going to be your condenser fan or your capacitor. Now we know we have some direction. It saves time, saves money. The technician's not going out there to diagnose. SAMMI is diagnosed for them. They're coming out with the right products to be able to fix that problem and get the refrigeration unit back online.
Well, I would assume at that point then, upon commissioning, the unit data would be inputted into SAMMI, so it already knows that it's dealing with this model.
That's correct.
Serial.
That's correct. Yeah. So there's a bunch of drop-down fields within the app, which the app is available on the iTunes Store and Google Play as well. So within the app, once you log in, you scan the barcode that's on the SAMMI that you're installing. That will prompt you to a bunch of drop-down panels that are specific to refrigerant use, whether it's high temp, low temp, medium temp. Geographic location is handled by the modem itself, so location isn't critical. However, location at your site is. So if this is going on compressor 1 out of 3 in a rack, you could name it smartly to say, hey, it's in this rack, it's in this room, even take photos and upload them so that when the technician goes out there, they're not searching for what one is rack 3. There's already a photo and kind of a map for them to go to.
That makes sense.
Yeah.
So on that front, is there a way that SAMMI can share either the data captured at the time of event or even just the live data as it's happening? Like before we even get there, let's say, especially if I'm trying to get familiar with this system,
Sure.
or I know that this is a special application, maybe SAMMI's had some trouble with this particular site for whatever reason. Like, can I see that information even though SAMMI's already recommended?
Sure.
Right?
Yes.
Can I see it for myself?
Absolutely. Yeah. So as I mentioned before, it sends a data pack every 5 minutes, but you can log in at any time and see the live snapshot of what's going on.
Okay.
So we do keep standard 30 days worth of data for each SAMMI. So you could even actually go back for 30 days and see if, there was a problem leading up to this that maybe you're unaware of. So we can also provide the data for 30 days prior to that event.
So, and a lot of the AI stuff we've seen, and quite a few people have tried to do some form of AI diagnostic models. Most of them I've seen have had varying success. I'll say it that way.
Yeah.
So one of my curiosities is, what data sets have you used to train your model with SAMMI?
So we have all the operating envelopes for each refrigerant in each application. So those are preloaded in, but a lot of these are not necessarily based off of a operating envelope. It's understanding how technicians diagnose problems based off of those 7 readings. So we took that inherent knowledge from our years in the industry of working specifically with compressors and saying, look, yes, the operating envelope for this compressor is this range. However, in this certain application, the range needs to be extended. The user also has the ability to push those limits to make SAMMI adjust to that. But once it gets outside of those parameters, it will still alarm. So the the data that we're using is data that's available to everyone, whether it's by manufacturer or by application or from the refrigerant companies. Um, we have 58 years of experience in this industry, and we've really relied heavily on that experience in our internal team at CSG to help set those initial boundaries.
Right. I mean, it makes sense.
Yeah.
Right.
Yeah.
And if I had to take a guess, I'd assume it's probably a self-learning model to some degree.
That's correct.
So
Yeah.
it's been a pretty common thing we're seeing roll out.
Yeah. So machine learning, the more data we can feed it, the more SAMMIs that are out there, the better it gets. So
Right.
if we have, 1 5-ton a residential unit with a SAMMI on it, well, it's only going to know one system's worth of information. But if we have 500 of that same unit out there, it starts to collect all that data, stitch it all together, and say, okay, well, here's a trend with this type of equipment
Right.
that then it's fully aware of.
I got you. So, for my interest, I start to think of larger scales and larger applications, even, right? So, I'm thinking with a screw air cooled chiller. We'll start there as an example.
Sure.
I mean, the readings you're already capturing, that's going to give you quite a bit of data, right? And there's a lot of older machines, because I could see, one argument you could make is a lot of modern controls packages, they can just backdoor into via a BACnet or Modbus,
Yep.
and they can pull all that data that way. And a lot of sites do that.
Correct.
There's a lot of machines that don't do that either.
Correct.
So it also takes it takes an automation system and an infrastructure, and it
Right.
takes all of that, and none of it gives you the AI side of SAMMI. So I see that positioning, if you will.
Right.
Right. So what is your vision on this being applied into something on a larger scale, like a air-cooled chiller, or even we could scale it to a centrifugal,
Sure.
applying this to a YK or a CVH application?
Sure. So what we recommend is with every compressor, there's a SAMMI for a multitude of reasons. We want to give the same readings and the same experience as if a technician was there on site, pulling readings from that machine. SAMMI is directly powered by the power supply to the compressor. So if we paired it with the system and the system still has power, but you've lost one compressor, SAMMI's not going to detect a problem. But if we're using the same power supply, SAMMI's going to know that this machine has lost power. The whole system may have power, but this one particular compressor is down. So that's the power of having one per compressor. However, there are some large systems out there that we wanted to take the temperature of water in, water out, right? Well,
Right.
that's really nowhere near a lot of times where the compressors are at. So we do have other solutions for that. So if you're looking to take compartmentalized information from other parts of the system, we can adjust the SAMMI to do that. They're fully programmable over the air as well. So someone like yourself who has a lot of experience with chillers, if you come across that application and you say, hey, I actually want to install this, but I want to install it over here and I want to read this. As long as we already have the preloaded programming for those sensors or whatever you're trying to measure, we can actually reprogram it over the air, and then you can use it for that application.
Well, one of the applications that I could see, let's stick with the centrifugal path, right? So we could, having the ability to read our water temps, we've already got pressure, so we could calculate our approach values at that point, which could really play a big role in helping us understand our heat transfer.
Right.
There's a lot of plants that, to be honest, they've got pretty poor maintenance, and because they don't keep up with their stuff as well, their approach values just steadily go up. But once you cross over a certain threshold, I could see a system like this prompting them more of, hey, you need to do some kind of maintenance here because
Sure.
your approaches have escalated, or you've already got condenser and evap pressure, and being able to calculate our lift conditions and be able to identify when we're starting to have some kind of lift event, right? High lift typically, which would then lead it into surging. And there's some machines that, they'll quietly surge themselves into oblivion, if you will, depending on how they're configured at the machine. And a lot of facilities and sites, I've worked with a lot of engineers on site.
Yeah.
They themselves have this concept that just chillers will just randomly surge and it's not a big deal, which has a small amount of truth to it. Right? An occasional surge can be expected, but that's not what's happening. Like they're dealing with very consistent, constant surging, and that's just when they're there to notice that it surged.
Right.
Right. So my mind goes to an application like that, where a system like this, even if they are pulling it into a BAS, that BAS, I know it doesn't have the logic behind it.
Correct.
It's just a monitoring system, and it's giving them some trends. But again, if you don't know how to interpret the trend,
Correct.
what it's not good for anything.
Right.
So that would be something I would be interested in seeing developed on this, is like profiles built around centrifugal compressors and like what their lift parameters would be, and being able to monitor a system like that. And if we see approach values spike, if we see lift values, and even correlating lift to load, because centrifugals work on a surge curve, and so the lower our load, the further down in that curve we get, the easier it is to surge. So that lift has to come with it. The system could be smart enough to analyze that data the same way a chiller tech would do. Like when we're there on site,
No, that's exactly right.
yeah, we're having to take that. Okay, I see that my evaporator TD is here, my condenser pressure is here. I know that I'm about here in the curve, and I can hear what the compressor is doing audibly. So that gives me some feedback.
Correct.
And by that standpoint, I can help guide that machine, if you will.
Sure.
Right. I can see the potential there on being able to take a system like this and build a profile around a centrifugal.
Right.
But one of the things about it, so I know we've got so this is the base model, right?
This is the SAMMI model. Yep.
So we got 3 temps, 2 pressures, a couple of currents and power.
Yep.
If we were to try to pull in water temps, do we have a larger module, or what does that look like on trying to get more inputs?
Sure. So we also have another product that we're not displaying here at AHR. However, it can be used in specialty applications. It's a SAMMI Junior. It has 2 inputs. So if we were looking to measure something else down line that didn't need the full capabilities of SAMMI, it can be programmed for temperature, pressure, amperage, whatever you'd like. And we can stitch those together. So SAMMI, because it uses GPS location, it will know that those are in the same location, but also within the app, you can put a parent-child relationship. So if this is your SAMMI that is at the compressor, but you also have some SAMMI Juniors out there, you can pair those SAMMI Juniors in the app for that same chiller, so that SAMMI knows to stitch all that information together. But to go back just a minute about your being the technician on site and listening to the compressor and knowing where you're at on the curve and so on and so forth, that's exactly the conversations we were having. But you and I both know that sleeping at a job site is frowned upon.
Right.
And so you can't be there 24 hours a day, but SAMMI can be there 24 hours a day. So even in a very specific case where you as a technician have identified a problem that your years of experience are pointing you to, we can apply a SAMMI to that job and verify your thoughts or concerns on that particular unit, but you don't have to be there. You can be going out earning revenue for your company somewhere else while SAMMI is logging the information. If you know that that approach value needs to be at a certain level before you want to be notified, because that's when you know where you're going to start surging, that's what we would pre-program into SAMMI, and we could help you with that.
So going beyond just, say, refrigerant pressures, so we have the SAMMI Junior. Is SAMMI Junior able to register a transducer for pressure as well? Because my mind goes to oil pressure.
Sure.
Right. So we get back into the centrifugal world. That's a huge part of our ability to monitor.
Yeah.
So would Junior be able to help with that, or is it just temperature?
No. So not to sound like a software guy, but if you can dream it, we can program it.
Right.
The SAMMI Junior has the full capabilities of SAMMI, just more limited ports. But again, it can read pressure, it can read temperature, amperage. It doesn't matter what.
All right. So then at that point, it's just a matter of having a centrifugal profile.
That's correct.
To program.
Yeah. Exactly.
Okay. That makes. I mean, it makes a lot of sense. I see a huge amount of potential. Yeah, I mean, so in what use cases have you already had for this system? And I mean, in terms of say testimonials, if you will, like
Sure,
what do you?
sure. So there's a couple that we can talk about pretty quickly and easily. One was an ice cream retail location, and the store owner had lost an entire freezer's worth of ice cream because the refrigeration rack that he had controlling that compressor failed overnight. All the ice cream melted. It was a disaster. We introduced this solution to them because it was a continual problem for them, and they were really trying to nail down why the compressor would fail so often, and we're really at a wit's end because of what we talked about before. You can't be there 24 hours a day. So what we did was install a SAMMI on that particular location, monitoring that equipment. But one of his concerns was people leaving the door open. This was the main freezer room. So what we did was install a SAMMI Junior above the door and measure temperature. So what we realized is that when they were loading and unloading ice cream out of the freezer, at times somebody would leave the door open. So the technicians, the store owner were all frustrated because nobody could figure out the problem, because the problem wasn't with the refrigeration equipment. The problem was with a person leaving the door open.
Which never happens.
Never.
Never.
So for the cost of the SAMMI, for the cost of installation, in the monitoring, this gentleman now can sleep easy knowing that he's not going to lose thousands of dollars worth of sellable products. And so that's one application. Another application that we have is at a industrial refinery, and we were monitoring equipment there for HVAC related issues, and they liked the capabilities of SAMMI, so we started applying it to some of their industrial equipment. And what we found was that the policies and procedures that company had in place for manual human interaction with the equipment and logging and monitoring temperatures and pressures and so on and so forth wasn't being followed. And we prevented them from having a catastrophic failure at their facility by noticing that a freezer room had lost power. And it was discovered that the policies and procedures that they had in place for human interaction had failed, but SAMMI had saved that company from that catastrophic failure.
Yeah.
So,
All right, and that's one of the banes of our existence as technicians
Right.
is when we're dealing with these facilities, we are very much at the mercy of the information that the on-site team can give us.
that's
And
correct.
they're not interested in revealing their own shortcomings.
And SAMMI's not designed to be a gotcha tool or even to remove the dispatcher or the human interaction from the system. What it's meant to do is make sure that the decision makers in the company that want their service teams to react and interact with errors in a certain way, that is followed every time. So we take the not human interaction, but the human decision making at the time out of it and only deliver results that upper management or service managers or owners want. So it's a powerful tool to sit down, go through the tree of questions, determine who can respond and to what events and to what customers, and then also review the equipment, make sure that SAMMI is set up correctly and to really watch it work.
Awesome. I like it. Well, I mean, I really do. It's another tool in the arsenal. Is part of what I'm thinking of,
Sure,
right?
right.
You know, I know there's a lot of buzz and hype and just AI everything at this.
That's correct. That's correct.
But realistically, amongst all the static and noise, there are some genuine things coming out of it that aren't just buzzy marketing gimmicks. That's what a lot of it, to me, feels like.
Right,
A lot of it
right.
just really comes down to they want attention. Throw some random ass AI thing out there, and you'll get attention,
Right,
right? Because
right.
everybody they just want to see.
Yeah.
But in that mix, the reality is there are opportunities for something like this
Yeah.
to come to the surface, and
Correct.
I'm excited to see where it goes. And we've worked together for quite some time
Yeah.
now, you know, and so I think we're on a good direction here.
Absolutely.
Really
Yeah,
do.
no, me too. And I appreciate your willingness to work with us. You've been a great partner for us in helping educate our customer base, our collective customer base, in the things that are out there. And again, AI is the buzzword, but really and truly, I mean, the points of data that we're measuring is going to be in your tool bag when you get to the site. All we're doing is making sure that those tools are always on. Then once there is a problem, we're letting somebody know.
I mean, in my absolute wildest fantasy, every piece of equipment is going to have a data logger stuck to it,
Yeah.
where I can go see what happened over the last several hours, whatever.
Yeah.
You know, realistically, my fantasies have a bit of legs now. So.
Right. Yeah, there you go. And so, with that, we're fully aware that, there are companies out there who have similar solutions for their chillers.
Yeah.
But what we also recognize is they were all brand specific. So one thing to note about Sami, it's ambiguous of brand. It doesn't matter if it's something that's small and residential or a centrifugal. It doesn't matter. Its pressures, its temperatures, its amperage.
Right. Yeah. I like it. I appreciate it.
Appreciate you. Thank you.